Work last night was worksheet number 4. We're going to take a look at questions 4 to 6 on that worksheet right now. I'm just going to copy this over, make a little bit more space. Now that didn't really create any more space, did it? Let's make that a little smaller now. There we go. Okay, so question number 4 says a car traveling at a speed of 10 meters per second accelerates at 2 meters per second squared for 3 seconds. What's the displacement of the car if it's speeding up or if it's slowing down? Well, look, in question number 4, we know that, well, some V is 10 meters per second. Can you tell me what that is? Is that V? Is that VI? Is that VF? Is that delta V? Is that the average? What is that? What would that correspond to? This car is traveling at 10 meters per second and then speeds up or slows down. This would be VI, right? This is the initial velocity. So I'm going to make it VI is 10 meters per second. Some's 2.00 meters per second. What is that? Sorry, meters per second squared. What is that? Acceleration. Is that positive or is that negative? In question A, it's speeding up at 2.00, positive or negative? We're going to make it positive, right? And the time interval here is 3.00 seconds. We want to find the displacement of the car in question A. So we're going to say, I don't know what. Is this group A or group B? I should have asked you that before we even wrote down givens, right? Is this group A or is this group B? This is definitely group B because it's accelerating. The only time we use V equals delta D over delta T is when it's moving at a constant speed or you're asked for the average speed or velocity. This is accelerating. It's group B. We've got to pick one of those 5 equations. Which one of those 5 group B equations seems to fit the best? It may be immediately obvious to you, and if it is, great. It may not be. You may try 3 of them or 4 of them before you get to the one that works. That's okay too. Which one do you want to try first? Which one did you end up getting the right answer with? Lucas? Or, Miguel? Which one did you do? Which one do you want to do? It doesn't have to be the one that gets me the answer. That's fine if it isn't.
VI times T plus 1/2.
Okay. So D is equal to VI times T plus 1/2 of A times T squared. That one? Miguel, this one?
Yes.
All right. Looks good. We've got VI, we've got T, we've got A, we've got T. We're looking for D, so this looks like it works, right? One unknown, looks like it works. So let's sub our numbers in here. Now let's say 10 times the time of 3.00 plus 1/2 of A, which is 2.00, times T squared, which is 3.00 squared. 10 times 3 is 30. 3 squared is 9, times 2 is 18, times 1/2 is 9. It's going to give me 39.0. 39.0 meters. All right, how many people got that? Good, good. It should be 3 digits, by the way. If you look up here, this is 3 digits, this is 3 digits, this is 3 digits. Final answer should be 3 digits. Now, how does this, yeah, go ahead.
How did you get
The what, sorry? Right here? It's the time, right? So this time is the same as this time, except that this time ends up having to be squared. So it accelerated for 3 seconds. So we're going to say that it's 10 times 3 seconds, 10 times the time, right? VI times time, plus 1/2 A times time squared. So again, 3 squared over here. Does that make sense? Okay. Okay, how does question B change things? I'm going to do this in a different color here. How is B different? It's almost the same, isn't it? Lucas, when you look at this question, what's different about question B than question A? Question 4. Okay, so what difference does that make mathematically that we're slowing down? Emily? Emily? Yeah, everything else is going to be the same except A is going to be negative 2.00 meters per second squared. We can use the same equation, right? If we have the same variables, the same equation is going to work, but you know we're going to get a different answer. If we're moving at a certain speed and we speed up, we're going to move a different distance than if we move at a certain speed and then slow down. We're going to go further when we're speeding up, right? We should expect to get a number that's smaller than 39 meters for B because we're slowing down. Not going to go as far. So let's write down the same equation, VI times T plus 1/2 of A times T squared. VI is 10 times 3, and it looks almost exactly the same, plus 1/2 of, this time it's negative 2 times, once again, T squared, which is 3 squared. Here we got 10 times 3 is 30, plus half times negative 2 times 3 squared is negative 9. Negative 9 this time, not positive 9. When we add those up, what do we end up getting? Now, what do we end up getting there? Nope.
I'm so sorry, I got that question wrong.
Okay. 30 plus negative 9? Chris, 30, you go ahead.
Oh, 30 plus negative 9?
Yeah.
That'd be 31.
Nope.
Wait, sorry.
30 plus negative 9.
Sorry.
No, that's okay. 30 plus negative 9, 30 subtract 9 is 21, right? Good. Actually, it should be 21.0. Let's take a look at number 5 now. Number 5 says a car traveling at 10 meters per second accelerates at a rate of 2 meters per second for 3 seconds. What's the final speed of the car if the car is speeding up, slowing down? This is almost the same question, isn't it? Just about the same, isn't it? We're going to say that VI is 10. This time, is this not exactly the same? Oh, we're looking for the final speed. Yeah, okay. So let's say 5A. 5A has all the same givens, doesn't it? Including the displacement is 39 meters. We now have an extra given, and we're looking for the final speed. We're looking for the final speed here. Now, we can use just the givens we started with, or if we want to, we can use the 39 meters for displacement as well to find the final speed. What do you want to do here? What equation did you try to get the final speed here? Marcos, which one did you try?
I use
Can't read your own writing, eh?
I think I accelerated it. I'm not sure what
Okay. Really? You couldn't make that one out? A is equal to delta V over delta T. Hey, it's a group B problem, right? So this is perfectly valid. A is equal to delta V over delta T. Now, it's not the only way we could do this. Now that we have displacement, we could have said VF squared is equal to VI squared plus 2ED, which absolutely would have worked beautifully. But A is equal to delta V over delta T does as well. Now, I want to rearrange this to solve for VF. Let's get delta V, because that's kind of like VF, right? Got to get rid of a T. T's on the bottom. We're dividing by T on the right-hand side. How do we take it over to the other side? We multiply it, right? So it becomes A times T is equal to delta V. Now, let's not worry about VF yet. Delta V is A times T. A is, what is it, 2.00? Times a time of 3.00 seconds. So my delta V is 6.00 meters per second. Is that my final answer here? No, I'm looking for final velocity, right? I didn't solve for final, I solved for change. If I started at 10 and my change was 6, then what's my final? 10 plus 6 is 16. Does that make sense? Okay, and B is almost the same again. We might as well use the same equation here, except B we're going to make green here. Solving for VF again, might as well use the same one. In fact, delta V is still going to be A times delta T. This time, though, it's not 2 times 3. It's negative 2 times 3. Because the acceleration is negative or it's slowing down, right, Kristen? Slowing down, A is negative. The time is still positive, still 3 seconds. That's going to give me, go figure, negative 6.00 meters per second. Okay, what's my final velocity here? If I started at 10 and my change is negative 6, what's my final? Started at 10, went down by 6. My final is going to be, what's it going to be? 4. So we're going to say 10 plus negative 4, sorry, 10 plus negative 6. Okay, one more. This one's question number 6. Puck moving on ice slows down at a rate of 3.00 meters per second due to friction. Puck is initially moving at 20 meters per second, comes to a stop. What's the displacement? This is, we don't know which way it's moving. North, south, east, west, right, left, up, down. Let's just make it positive. It's moving positive. What do we have given to us in this one? Oh, yeah, slows down at a rate. That should be 3.00 meters per second squared. Slows down at a rate. That's not speed. That's acceleration, right? It slows down not to 3 meters per second squared, or 3 meters per second, but at a rate of 3 meters per second squared. Is that a positive value or a negative value? Rochelle, is that positive or negative? We're going to make it negative because it's slowing down, right? So A is equal to negative 3.00. What is this 20 meters per second thing? Is that VI or is that VF? Oh, you got this, right? And what is that, VI or VF? Yeah, that's the initial velocity. And we're just going to make that positive, assuming it's moving in the positive direction. Initially moving at 20, comes to a stop. We want to find the displacement here. Is there anything else that I have if I read between the lines here? Yep. Good. VF is 0. So it's given to me, right? But I have to look for it to find it. Now, is this group A or group B? Should have asked you that question before we wrote down givens, but group A or group B? John? Yes, it's group B because it's slowing down, right? So we know we can use one of those 5 equations. Which is the only equation that we've learned so far that we can't use? Oh, you guys, come on. V is equal to delta D over delta T. We cannot use, right? Which one do you want to try here? On your data sheet, those 5 group B equations, A, VI, D, VF. How about this one? Do you have A? Delta V, VI, VF? Yep. T? No. You could solve for T here, right? But that's not what you're looking for. Now, that's right. It's still okay because you could use the time in another equation to help you solve for the displacement, right? That's fine. It's not what I did. How about this one? D is equal to VI plus VF over 2 times time. Is that a valid equation? Absolutely. VI, VF, good. Don't know what D is, don't know what T is. All right, that's not very helpful to me, right? 2 unknowns. Didn't get the wrong answer, though, did I? How about D is equal to VIT plus 1/2 AT squared. Is that a valid equation? We're allowed to try that one? Absolutely we are. Got D? No, don't have that. VI? Yep. T, nope. A, yeah. T, no, too many unknowns, right? D is equal to VFT minus 1FAT squared. Same thing. The only one that I think finds the answer, bless you, right away is this one. And this is probably what gave people trouble. I know that some people had trouble with this one. How many people looked at this and said, I think that's the one that I want to use? Yeah, except that it's kind of hard to rearrange, right? We've got VF, we've got VI, we've got A, solving for delta D. Now, bear with me on this, okay? I'm going to go through the steps in rearranging this. Remember this going forward for every equation. Like, you got no chance of rearranging this using that silly triangle rule, right? Zero chance. So you need to know more. Here's what I want you to remember. Rule number one, get rid of what is not attached by doing the opposite. Rule number two, get rid of what is attached by doing the opposite. Okay, so what's not attached? Remember, rule number one, get rid of what's not attached. What's not attached to delta D there? Nick? VI squared. Okay, so get rid of what's not attached, VI squared first, by doing the opposite. It's added, so we're going to take it over by subtracting. Good. So it's going to become VF squared minus VI squared equals 2AD. Is that good? We get rid of what was not attached by doing the opposite. Rule number two, get rid of what is attached by doing the opposite. What is attached to delta D? 2 and the A. They're multiplied by D, right? So how do we take it over? By doing the opposite, we divide. Now be careful of this. It's the entire thing divided by 2A on the left-hand side, right? It's not just VF divided by 2A. It's VF squared minus VI squared. That's what we had on the left side. Divide that whole thing by 2A. And that gives us delta D. Does that make sense? Get rid of what's not attached, then get rid of what is attached. Now, if you have a square in there or something like that, it becomes a little bit trickier, but generally that works. Get rid of what's not attached, get rid of what is attached. Okay, now comes the substitution into the equation, which I don't know if it's any easier than the rearranging was. We're going to say D. I'm just going to make D on the left side and VF squared minus VI squared over 2A on the right side. I can do that, right? Switch the sides, just a little neater. VF is 0 squared minus 20 squared over 2 times negative 3.00. Now, take out your calculator and do this with me, okay? Everybody do this with me. We're going to say 0 squared, although we didn't really need to, because what's 0 squared? 0. Subtract 20 squared. I want to press equals. Once I get the number on the top, I want to press equals. Negative 400 on the top. Now, let's divide that by, here, don't enter this, okay? I'm going to do it wrong. Okay, I want you to tell me, it's going to give me the wrong answer. I want you to tell me what I did wrong on this, okay? So far it's right. This is correct. Negative 400 divided by 2 times negative 3 gives me 600. It's the wrong answer. How should I have entered this? How should I have entered this, Gabby? Yes, I should have said negative 400 divided by bracket 2 times negative 3. If I go 2 times negative 3 without the bracket, then what your calculator assumes is that you're dividing 400 by 2 and then multiplying the whole thing by negative 3. We want to multiply the bottom by negative 3. So make sure you got those brackets. I get 66.666. You know why this question was so hard? You know why this question was so hard? Because it's the double question, right? 66.666. 66.7 meters. Make sense? I just saw an announcement this morning for curling. Anybody a curler here? Anybody going to try out for the curling team? You should. You should try out for the curling team because now you can figure out how far the curling rock is going to go. All you need to do is take your calculator out and your pen or pencil out of your pocket protector. Make sure you got the tape on your glasses, in case so that they don't, in case they break when they hit the ice when you're curling. Calculate how far the curling rock is going to go, and you're going to nail it. Like you're going to get that shot right every time because you can calculate how far it's going to go now. Yeah. Really? Is that right? Oh, that's go crazy now. That's like almost like baseball statistics they're using there. Yeah. You guys, are you good with that? Let's do one more example here before our break here. Example number 10. It says a rock falls from a height of 50 meters above the ground. What's the speed when it strikes the ground? We got one thing given to us here. 50 meters. It's gravity, right? Yeah, we have gravity. What is gravity? Yeah, we're going to make it negative 9.81 because it's going to speed up in the negative direction, right? We're going to say A is equal to negative 9.81 meters per second squared. And we're going to make, what is this 50 meters thing? Yeah, you could call it height, but we don't actually have any equations with height in it, right? We're going to call it, what is it, Marcos? We're going to call it displacement, yeah. Now, be careful here because we're missing something. Okay, what's the initial speed? If it falls from this height, the initial speed is going to be 0 if it's dropped, right? 0 meters per second. We're looking for the speed when it strikes the ground, right? VF, speed when it strikes the ground. There's a small mistake that I've made in here. Who can spot it? Emily, what is it? Okay, I'm asking for speed, not velocity, but I've got that, right? I said V, not with a little arrow over it. I said it without the arrow, so that's right. Yeah, no, that's okay, because acceleration is still negative, okay? Just because we're looking for a scalar, acceleration is a vector, so we still include direction with that, okay? That's a good point, but yeah.
If you're considering up as a positive direction.
Yep. Yes. Displacement is negative 50 because it's down, right? We're making up positive, down negative. Probably should have defined up as positive there, and then that becomes a little bit more clear, right? All right, is this group A or group B? It's B, right? It's accelerating. So which equation do we want to use? Which equation do we want to use? Oh, there's lots of options, 5 of them, right? How about A is equal to delta V over delta T? Well, if we do that, we know A, we know delta V, or VF and V, or we know VI, we don't know VF, we don't know what T is. That's not going to help us, right? Nick, what do you say? Okay, that's the second one we wrote down. That it doesn't matter if it's the first one or the 5th one that you write down, you're going to get this, right? Sooner or later, if you keep cycling through, you've got to get to the equation that's going to work here. VF is what we're looking for. VI we've got. A we've got. Delta D we've got. Perfect. Okay, now, how do you rearrange this to solve for VF? The only thing we got to get rid of is the square. What's the opposite of square? Square root. So let's say VF is equal to the square root of VI squared plus 2AD. Notice I'm square rooting the whole thing though, right? When I do something to one side, I got to do it to the opposite side, the whole opposite side, not just one term. So VF is going to be equal to 0 squared plus 2 times negative 9.81 times negative 50. And we're going to square root that. Square root that. Okay, let's do this on the calculator as well. We're going to say 0 squared minus, now watch this. I'm going to put that all in one set of brackets, that term 2 times 9.81 times 50. 2 times negative 9.81 times negative 50. See what I've done there? Now I'm going to press enter, negative 981, and I'm going to square root that. Wait a second. Oh, it should have been a plus up there, right? It should have been, that should have been a plus. So 0 squared plus 2 times neg 9.81 times neg 50, 981. Got it? How do I know it had to be wrong? Well, that's not a final answer, right? I still have to square root this. That's just inside the square root sign. How did I know that I had done something wrong, that I had made a mistake? Alex? Yeah, I had negative 981, and I can't square root that, right? Or at least in physics 20, we can't square root that. Gives me 31 meters per second. Now, this question asked me for final speed. I got 31 meters per second. What if it had asked me for final velocity? Yeah, we would have said 31 down or neg 31. When I solve this, it's only ever going to give me positive. But notice in this equation, it's designed to find speed, not velocity. So this will always give you speed. If you're looking for velocity, that's okay if you're looking for velocity. But if you are, you're going to need to add the velocity in yourself after the fact to make it negative. Good?